All right, welcome back. Again, it was great seeing everybody last week. And you make sure to email me for any questions about how to raise your grade and kind of what the expectations are. So it's good. I haven't got any questions yet, but I'm recording this on Friday, so we'll see how everything goes this weekend. All right, so moving on. Again, we're only teaching the essentials of logarithms, which means that we're not going to teach you guys some of the more complicated problems or even domain and range, which could be a little tricky, but we want to make sure that in this situation, we're preparing you for the final as best as we can. So we're going to take a look at some properties of logarithms, and hopefully these look somewhat familiar to you guys because they are very similar, or in fact, they come from the exponent rules. Okay, so let's take a look at some of these first ones here. Log base b of b to the x power is equal to x. Log base b of b equals 1. Log base b of 1 is equal to 0. Let's talk about this one specifically. And if you think about what a logarithm is, it's asking the question, what do I raise this base by to get me this exponent? And so what this is saying is b to the 0 is equal to 1. Well, that makes a lot of sense. And what this is saying is b to the 1 is equal to b. Well, that makes a lot of sense. And what this is saying is b to the x is equal to b to the x. So if you raise a logarithm with the same base up to the same power, whatever the exponent is, you can kind of think of it as like canceling out. Here's another one, and again, this is very similar to the exponent rules. So if you guys remember, if I have a to the m times a to the n, it's the same thing as a to the m plus n. Well, that's all this is saying here. If I have log base b of p times q, that's log base b of b plus log base b of q. All right, down here, same thing as the division algorithm here for exponents. A to the m divided by a to the n is the same thing as a to the m minus n. And for logarithms, it works the same way. If I'm dividing two logarithms, I can rewrite it as subtraction of two separate logarithms. This is the part where a lot of students struggle because they forget that it's two separate logarithms, and some students will say it's log base b of p minus q, but you have to include both logarithms. Over here, the log of a number to a power is the power times the log of the number. All this is saying, and this is again a nice property, is I'm allowed to move this exponent and to a coefficient. And this is probably one of the biggest properties of logarithms that we're going to be using in order to help us solve sometimes unsolvable exponential questions, or at least we think they're unsolvable, but they're really not. Over here, this is kind of similar to this one. They're closely related. If I raise an exponent, a base to the same log base, so b to the log base b, notice that they're exactly the same here. It's just equal to whatever the exponent is. So all they did here was just move this exponent to the front, the reverse of this rule up top, and now it's equal to the exponent. So the base raised to the log exponent with the same base is the input of the log. And lastly, this is something that you're going to use, especially if you don't have an updated TI graphing calculator, and this is the change of base formula. So mark this down, and I'll refer back to this in our notes here. But what this is saying is if you have a base that's not known, remember your calculator only has two buttons for logs. It has log, which we know is log base 10, and it has ln, which we know is log base e. So if it's anything other than these two things, unless you have a new calculator, and a lot of you guys do, but I know there's some of you guys that don't, unless you have a new calculator, you need to use this formula, right? And if you have a new calculator, unfortunately, I will show it on the screen here, you can figure it out just by pressing second, I believe it's second window or alpha window, and you'll get that log button. Okay, so play around with your calculators and figure it out. Otherwise, this is a really nice formula because it's all just saying is if you have a base that you don't know, so something other than e or 10, you're allowed to rewrite it with a base that you do know. Okay, so we'll get into this one specifically, but out of all these properties, these two are going to be the most useful. I mean, these are also very useful as well, but they make sense because they come from exponents. So let's kind of get a feel for this. Again, I'm going to go fast here because you guys could just pause, and I don't want these videos to take a very long time. So log base b of b to the x is equal to x. Okay, so log base 4 of 4, well, this is really like saying 4 to the first power, 6 to the first power, e to the first power. And so all these are all equal to 1, 1, and 1. So now this is using this property here. Okay, so what do I raise 3 to get me 1? Well, this is 0, this is 0, this is 0. So anytime you have a 1 as your input, we know that it's going to be equal to 0. And lastly, this c comes from over here, where you could just take base b of b to the x of the input, and it's just the exponent. So all these are just going to be the exponent because these two bases, you can kind of think of it as like they cancel out. Okay, so this is 5, this is 2. Now why is this 3? Again, we have to make sure we make this connection that anytime you just see a plain old log, plain old log, that really means log base 10. So what we're looking at here is log base 10 of 10 raised to the third power, which is just 3. All right, so now moving on to another property. So we usually call this expanding. So if you have log base b of p times q, it's log base b of p plus log base b of q. When we make the review for the final, there's going to be a redonkulous question on there that's condensing, or basically taking this and going backwards. Right? So we'll teach you guys how to do those kind of problems here. So log base 6 of 9 plus log base 6 of x. So we can condense and write it as a single logarithm. So log base b is 6 plus log base 6 of x. Since the bases are the same, we could just rewrite this as log base 6 of 9x. Over here, there's different bases, so at this point in time, there's nothing we could do about these two, okay? So kind of just cross this one out. Now, log base 3 of 14 minus log base 3 of 2, well, they have the same base, so I could just rewrite this as log base 3 of 14 divided by 2, which is log base 3 of 7. Okay, so that's kind of how condensing works. Okay, over here, same bases, okay? So log base 7 of 2 plus log base 7 of 5 plus log base 7 of y, well, that's going to be, just since it's plus, it's going to be log base 7 of 2 times 5 times y, which is log base 7 of 10y. All right, again, over here, plus sign, notice the parentheses. Okay, you can't just ignore those things. So if it's a plus sign, same base, it's log base b of x times 1 plus x. Yes, you can expand it if you want to, but there's really no point in doing that. And the last one for this one here, this kind of problem, we see the subtraction. Okay, so we got to know that if it's subtraction, you can rewrite it as division. But again, this only works, again, if you have the same logarithm. If this was just natural log of x minus 2, there's nothing you could do here. This stays, okay? You can't change it. But what you have to pay attention to, and again, this is like when you get to higher level mathematics, it's really about those details. These both have a natural log here, and you're subtracting the same base. So now we can just rewrite this as a natural log of x over x minus 2. Now this is kind of a fun problem. It's it's doing order of operations here. So we go from left to right, right? So log base 4 of 5. Again, notice they all have the same base, so we're good. And we have minus, plus, and a minus. Okay, so you could go in little pieces. You could say, well, log base 4 of 5 divided by 2 plus log base 4 of a minus log base 4 of b. Okay, and then you do it again. Notice a plus sign. So then you do log base 4 of 5 divided by 2 times a minus log base 4 of b. I don't know what happened to the b here. I don't even know what that is. And then again, notice there's a minus sign, so then we know we're going to be dividing by b. So we rewrite this as log base 4 of 5a over 2b as your final answer. Now, some of you guys may have looked at this and said, like, oh, yeah, I could have seen that from here. 5 divided by 2 times a divided by b, right? And that's great if you could see it that fast. I know not everyone can do that, so it's okay to do that in steps, okay? So once you try, hit the pause button and try the second problem here. Okay, so now notice, they all have the same base, which is good. That means we can move on. So plus, minus, minus. So plus tells us we're going to multiply. So log base 5 of 6 times 2 minus log base 5 of 3 minus log base 5 of d. So again, I'm going in steps, but some of you guys are going to be able to see things faster and do it in your own way, which is fine. So now this becomes just 12. So log base 5 of 12 divided by 3 minus log base 5 of d. And again, 12 divided by 3 is just 4. So now we have log base 5 of 4 divided by d as our final answer. Okay, so hopefully some of you guys got that. All right, so this is kind of a natural break here. This is the first page. So I'll stop the video for now, and then I'll continue it on the next page.